Okay, good morning everyone. Hopefully again you guys are having a great time. So today what we're going to do is we're going to talk about adding polynomials again, and then we're going to work on from adding to multiplication, right? That's what we learn in math. We go adding quickly, subtracting, and then we're going to do multiplying. And that's what we're going to head off. That's the direction we're heading today. So today we're going to go do a quick review using an application idea, which will also be on your homework today. And we are going to use perimeter. Oh, that looks terrible. Perimeter as our example today. So let me give you an example of a triangle here. Let's say this triangle has not numbers, but let's use letters. So if I say 3x, 4x plus 2, and 6x minus 4. Okay. And actually, what's a perimeter? And the idea of a perimeter is adding up all the exterior sides. What is the distance around my shape here, right? By adding up all those sides. So what we're going to do here is we're just going to add all the sides together. If this was a easy number, if I said this was let's say the triangle was something like 5, 4, and 6 here, the perimeter would be 5 plus 4 plus 6. So the perimeter here would be 15, because the perimeter is a distance around my shape, whatever that shape is. If I ask you walk around the perimeter, you might have heard this in gym class. Walk around the perimeter, that means you have to walk all the way around, right? Not through, no cheating. You're going to walk all the way around. So for this problem here on my left, using variables, we combine like terms like we did before. We combine 3x plus 4x plus 2 plus 6x minus 4. Okay? So our perimeter is adding up all three parts. And then we're going to look at like terms. So we see that 3x, 4x, and 6x are like terms. 3 plus 4 is 7. 7 plus 6 is 13x. And then we have our 2 and our 4 here. And 2 minus 4 is negative 2. So our perimeter would be 3x minus 2. Simple as that. So that's what you guys are going to do on your homework today. You're going to be adding up the perimeter. And this is just another practice and application of what if you were adding up values that weren't numbers? What if they're variables? So we always combine like terms together. X's of the same level together. Let's do one more just as we go through this. If I give you a type of quadrilateral here, let's say this is 4x plus 2, 6x minus 5. We'll call this 3x plus 1 and 3x plus 4, right? So what is the perimeter of this shape here, this quadrilateral? Well, we just add up the four sides. The perimeter is 3x plus 4 plus 4x plus 2 plus 3x plus 1 plus 6x minus 5. Again, we're just adding up all the sides, and we have to use our skill of, hey, we have some like terms here. Now, you can draw an arrow around these. You can highlight them however you want. You can just look at them with a dirty look. So 3 plus 4 is 7. 7 plus 3 is 10. 10 plus 6 is 16x's. See, we're just adding the 3x plus 4x plus 3x plus 6x. And then we're going to combine the 4 plus 2 plus 1 minus 5. Now, you don't have to write this line here. This is just for me to demonstrate to you guys what I'm doing. So when I add up all the x's, 3x plus 4x is 7, 7 plus the 3x is 10, and that 10 plus the last one, 6x, adds up to 16x, okay? So why don't you guys do the numbers for me real quick? Let's see if you guys can add those quickly. Okay, I'm seeing 4 plus 2 is 6, 6 plus 1 is 7, 7 minus 5 is 2. And that's our perimeter here. Just adding up all the sides. Again, if you practice the last skill of adding polynomials together, this isn't that big of a step. This is just an application of it. And sometimes kids get scared. They're like, oh my gosh, I need numbers. Well, no, we can add variables too. And it's something we've done before. Now, today we're going to move on to multiplying polynomials, okay? We're going to be multiplying polynomials today. We're going to be doing it in two phases. We're going to be multiplying by our basic monomial, just multiplying one thing into a polynomial equation. Then we're going to multiply polynomials by polynomials. All right, we're going to get pretty messy pretty quickly. But we want to make sure we have some good habits. So let's go ahead and get started. We're going to say 3 times x plus 2. Okay? So starting out with a really basic idea here of 3 times x plus 2. Well, if you want to go through the classic approach, isn't multiplying adding? So I'm adding x plus 2 3 times. And this is a monumentous, likely slowest way possible. If I give you another example, if I said 3 times 5, right? It's 5 once, 2, 3 times. Very similar to what we did here, except instead of writing 5, I'm going to write the whole binomial here. Binomial meaning two terms. X plus 2 are two terms, binomial. I use the word binomial, binomial. Binomial. So what's the difference between me adding, using multiplication as addition, like 3 times 5 is 5 plus 5 plus 5, or 3 times x plus 2, which is just x plus 2, x plus 2, x plus 2. There's no difference. It's just we're looking at it in a different way using different objects, I guess. Well, if I'm adding x plus x plus x, isn't that 3x? And 2 plus 2 plus 2 is 6. Now, how could I get from here to here in a faster way instead of me having to always write out each of these things I'm multiplying? Imagine if I had to multiply this 10 times. Okay. Maybe you guys have seen it. If I just multiply 3 by the x and 3 by the 2, all right, that's it. When I'm multiplying into a parentheses, remember we distribute that number, and that's what we're going to do. A faster way is to say 3 times x is 3x, and 3 times 2, let me write it this way, plus 3 times 2, right? I'm multiplying 3 to everyone. 3 got distributed. It's almost like this is a relief package. You get a 3, you get a 3. Everybody gets a 3. You could consider this a stimulus check from the government. You get 1,400, you get 1,400, everybody gets 1,400. So we end up with 3x plus 6. Same answer, but we save a lot of more time. Let's do this with another easy number. If I say 3 times x squared plus 4x minus 8. Again, I could write this 3 times, which I am not going to do anymore. Because hopefully I convinced you that multiplying is faster than addition. So if I multiply, you get a 3. Who else gets a 3? You get a 3. And you get a 3. So let's go ahead and do that. I'm going to write it out once the long way. 3 times x squared plus 3 times 4x plus 3 times negative 8. Okay, see, I'm multiplying 3 by everybody. I'm distributing the 3. So 3 times x squared is not 3 to the 6, sorry, not x to the 6th power. The 3 is a constant in the front, so 3 times x squared, I have 3x squares. How many 4x's do we have? We have 3 times 4, we have 12 x's now. And 3 times negative 8 is negative 24. Yes, it could be that easy. Okay. Let's introduce a variable into the mix. What if I say 3x squared times x squared plus 4x minus 8? Okay. Now we're going to use a couple of skills that we learned about 2 weeks ago about multiplying exponents. Here we go. I'm going to write this long way first. Okay, 3x squared times x squared. This is just our learning phase. You don't have to do this in your actual work later. Plus 3x squared times 4x plus 3x squared times negative 8. So very similar to what we did here. So this is what my brain is doing. My brain is actually sharing the 3x with the front. Then I'm sharing the 3x with the 4. Then I'm sharing 3x with the negative 8. So I'm doing this part in my brain. This is brain work, okay? You don't actually have to write this, but I'm writing it down so you guys can see what's going on in my brain. So when I'm multiplying 3x times x squared, I'm thinking, okay, that's 3 times an divisible 1. 3 times 1 is 3, and x squared times x squared. How many x's do we have now? X squared times x squared. That's x to the 4th power, because we add our exponents. Please, as a reminder, x squared times x squared. I have 1, 2, 3, 4. I have x to the 4th power. Or the fast way is x 2 plus 2. If I'm multiplying powers, I'm adding exponents. If I'm multiplying powers, I am adding exponents. Let's look at the next one. We have numbers in front. We have 3 and a 4. 3 times 4 is 12. And x squared times x is x cubed. Let me illustrate that over here. X squared times x is 1, 2, 3. Oh, we have x cubed. Or the short way, 2 plus 1 is 3. The last term here, I'm seeing a number and x squared. Well, 3 times negative 8 is negative 24. And we don't have any exponents on the 8, so it's just x squared. That's it. It could be that easy. If you can crack in your head, if it makes sense in your head right now, you're in a good place. Now, how do you get better at this? You just keep doing it. The more you do, the faster you go. Okay, you guys are doing big math now, guys. Okay, so let's do one more fancy one. If I say 5x squared y, okay, times x squared y squared plus 2x squared plus 5y cubed. Okay, now this is a big fat mess. This is a big fat mess. We multiply, 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 and we're going to combine them separately. So I'm going to write this out, what's going on in my head. I'm multiplying 5x squared y times x squared y squared. Then I'm doing my next round, 5x squared y times 2x squared. Then I'm multiplying 5x squared y times 5y cubed. I'm sorry. So that's what I'm doing in my head. I do not have to write this line. This line is going on in my head right now. So what happens right here? Well, 5 is my only number, so it's 5. How many x's do we have now? X squared, we have x to the 4th. Y squared, we have y cubed. Take a look, we're just adding exponents. We're pretty much doing what you did individually, but all in a row now. Before, when we practiced this in Excel, we just did one problem and we stopped. We did one problem and we stopped. We did one problem and we stopped. But now hopefully that you're faster at this skill, we're doing them all together. Let's look at the next one. 5 is my number, 2 is my number. 5 times 2 is 10. How many x's do we have? X squared, we have x to the 4th, and we only have one y left. Okay, the last one, 5, 5. 5 and 5, right? Those are my numbers. Hopefully you can see that's 25. I don't have any x's here, no x's, right? So we only have x squared for everyone, but we have y, 1 here and 3 here, right? 1 and 3 here. We have y to the 4th power. Okay, if I'm multiplying powers, I'm adding exponents. Wow, if you guys can do that, you guys are in great shape. Okay, so whenever I'm multiplying something in the front, we multiply it to everybody by taking its turn. Okay, everyone takes its turn, which isn't a hard task. Okay, Now, what if I have two things to multiply? Now we'll start off here with saying x plus 3 times x plus 2. Okay? This is a binomial times a binomial. Two things times two things. Now, I want to go ahead and give you an example of this using numbers. Okay? What if I wrote 23 times 22? How would you normally have done this? So back in Algebra 1, back in like 3rd grade, you learned multiplying two numbers. You would say something like 23 times 22, right? Isn't that what you guys would do? And then you go about the task of multiplying everybody by everyone. You don't think of it that way, but that's what we did. We said 3 times 2 is 6. And then who do you do? Are you done with the 3? No, then you multiply 3 by the front 2. 3 times 2 is 6. You guys remember that? Okay, are we done with the problem? Nope. Now it's the 2's first. But it's not just a 2, it's actually a 20, right? This 2 here is actually a 20. That 2 here is actually a 20. So we say 2 times 2 is 4, right? So remember how we put a 0 over here at the end? And 2 times 2 is 4, because it's not because it's just 4, because it's actually 40, right? It's actually 20 times 2. That's why it's a 40 there. You guys see how it's a 40 now? And we say, what's 2 times 2? We say 4. But you know what? That isn't a 4. That's actually a 400, because it's 20 times 20. See, this is actually a 20, and this is actually a 20. So 20 times 20 is actually 400. And then we add them all up. Now, I want to talk about this one more time. Let me do this one more time to talk about what we actually did in elementary school. So if we say 22 times 23, you said, okay, start with a 3, right? 3 times 2, and then 3 times 2. And if I think of this as numbers, I'm saying 3 times 2 is 6, and 3 times 20 is 60. And that's 66, right? 3 times 2 is 60, and 3 times 2 is 6. Okay. Now I'm done with the first number, then we use the 2. Then 2 times 2. And then we write a 4 here. Remember, your teachers always taught you to put a 0 there. Why? They said, just do it, okay? Because you're on your next row. But the reason why is this is not a regular 2. This is actually a 20. And what is 20 times 2? 40. See, that's why it's a 40. What is 20 times, this is not just a 2. This is actually also a 20, right? 22. 2 times 2 is 4, and you normally would write a 4 here. But it's actually 400. So I want to just talk about what we did back in the day. We multiplied everybody by everybody, right? And then you combine like terms. 40, going backwards. This would have been 6, and that's a 10, carry the 1, and 506. Now the skill that you're learning in algebra is no different. But instead of saying 20 plus 3, and 20 plus 2, we're going to leave that variable as x, because x can be, in a sense, anything we want. Okay? X is going to be that variable, and it can be shifting around. So this is, instead of saying 23 and 22, right? 20 plus 3 and 20 plus 2, I'm going to use x as a variable. And we're going to do exactly what we did here, except not in such a complex way of writing a new thing over there. We're going to do what we've been doing, the distributive property. So what we're doing here is we are going to multiply, let me write this in a fancy way. We're going to multiply x by everyone in the back, right? It's going to take turns. Another example is, ever have a big family party where your family is meeting a distant family, and you guys line up together, or when they come in through the door and your dad introduces you guys, this is my daughter, this is my son, this is my wife. And then the other person says, this is my daughter, this is my son, this is my wife. And you guys all like shake hands, right? Sometimes do this at funerals or at weddings, right? Where you all line up, and then every person in your family shakes hands or gives condolences, right? That's what we're doing. X's turn is going to line up and say hi to x and say hi to 2. Through what type of activity? Through multiplication, because we are multiplying them together. So let's say x, here's the big idea. X times x plus 2. That's what we're doing. X is going to multiply x plus 2. Okay? Then we're going to add a 3 times what? X plus 2 also. So take a look here. We are going to multiply not only x by everyone, but now we're going to multiply 3 by everyone. So what I wrote here in my second line is just an idea of what I'm doing. I'm saying x multiplied by everyone in the back, and now 3 multiplied by everyone in the back. Now, do you have to write this second line? Nope, I usually skip it. But a lot of books like talking about the second line where I'm multiplying x by everyone and then 3 by everyone. But what are we actually doing? We're saying monomial multiplication again. X times x is x squared. X times 2 is a positive 2x. 3 times x is a positive 3x. And 3 times 2 is a positive 6. Now, 99% of the time you will have like terms, so look for those like terms. Do I see any more x squares? Do I see any more x's? And do I see any lonely constants? So let's combine our like terms. We have x squared has no friends. 2x and 3x are buddies. They become 5x. And 6 is by itself. Okay. So whether you jump into my second line here, which is great, or go directly to home, so go directly to home and click 200, you can also just jump here. Right, both of these are totally cool places to go. Let's go ahead and do another problem like this. If I ask you guys to multiply x plus 4 times 2x minus 3. Okay. So we can write this of 2 ways. Now I'm going to write this for your brain first. X times 2 and x times 3. So x times 2x minus 3. It's your turn. Right? You can almost think of this like taking a shower. You take a shower, you do shampoo and conditioner. All right, then the next person takes a shower, they do shampoo and they also do conditioner. Everybody has to multiply everybody. That's plus 4 times 2x minus 3. Now, writing this move here is just for your brain. It's just to remind your brain what you're doing. I'm multiplying x by everyone and then 4 by everyone. That's a positive 4. But really, we could just work from this point. X times 2, let me go ahead and erase this real quick. X times 2x. Folks, what's x times 2x? What's x times x, we said? That's going to be x squared, 2x squared. Okay, then x times negative 3. Okay, that becomes negative 3x because it's an invisible 1 in front. All right, am I done yet? Did we finish multiplying everybody by everybody? Nope. Now it's the 4's turn. Here we go. 4 times 2 and 4 times 3. 4 times 2x is 8x, and 4 times 3 is negative 12. Really, make sure you have an orderly pattern that you have in your brain that works for you. Now that we've multiplied everyone, okay, 2 times 2 gives us 4 terms. We should have 4 terms here. I have 2 in the front, 2 in the back, 2 times 2, that's 4. Now do we have any like terms? Take a look. Hopefully you guys have noticed that the 3x and the 8x here are like terms. 2x squared plus 5x minus 12. Okay, 2x squared plus 5x minus 12. And this is a major, huge thing about algebra, multiplying binomials together. We'll be doing this for quite some time. Let's do another one. Oh, actually, let me give you a let me show you why this is kind of cool. What if I told you x equals to 2, okay? If x equals to 2, for x plus 4 and 2x minus 3, is that really the same as 2x squared plus 5x minus 12? Okay, and I want to test this with a real number. If x was 2, let's go ahead and figure out what this would be. if x was 2 and x was 2, and x was 2 and x was 2, let's plug it in and see if they give us the same answer. Would our original two factors being multiplied together be the same as this huge polynomial of 2x plus 5x minus 4? 2 plus 2 is 6. 2 times 2 is 4, right? 4 minus 3 is 1. You're telling me this whole thing in the back is going to be just 6 times 1? Well, let's see. 2 squared is 4. 5 times 2 and minus 12. That's 8 plus 10 minus 12. 18 minus 12 is 6. Yes, whether we plug in x at the beginning or at the end, we end up with the same exact answer. Why? Because these are equivalent statements. We're just multiplying them together. What's the difference between 2 times 3 or me writing the number 6? Is there any difference between me writing 2 times 3 or just me writing the number 6? Nope. Now again, if you look at here, you can see all the work I'm writing here. I expect you guys to be able to show this work when you guys take your test. You guys should also be practicing when you guys are doing your homework, so you don't make these simple mistakes that oftentimes people mess up in. They mess up oftentimes on the negatives, they mess up on the exponents, they mess up on combining the like terms together. So a lot of those different places where you can make simple mistakes. If I try this with another number like x equals to 5, it'll give me the same answer. Okay. Okay, let's go ahead and let's do one more. I want to use this as our last example. X plus 7 minus 3x plus 2. Okay, let's see what happens here. I'm going to give you guys a moment here to see if you guys go ahead and let you guys multiply this out. Go ahead and multiply that out yourself. Give you guys a moment. X times everybody. X times everybody. And then 7 times everybody. Right. You're going to end up with some like terms in the middle. Go ahead and combine those. I'll give you guys another 15 seconds. Another way to look at this is x times 3x plus 2 first, then 7 times negative 3x plus 2. Okay, hopefully that was enough time for you guys to at least multiply them together. So x times negative 3x is negative 3x squared, then x times 2 is 2x. If you did that over here, x and x, okay, same process. Now multiply by 7. 7 times negative 3 is negative 21. And 7 times 2 is 14. Same thing if I did over here. Minus 21x plus 14. Hopefully you guys notice we have like terms now. 2x and 21x. Negative 3x squared. Minus 19x plus 14. Okay. All right, that's it.